Here is another example with the inverse Laplace transform. Here I have repeated pole. So whenever you see s square is nothing but it has a pole at s equal to 0, and that pole is repeated in this case. Okay, so since the order is 4 for this given system or given transfer function, we have to split into 4 individual terms. Okay, so it's a over s plus b over s square plus c over s plus 2 plus d over s plus 3. Okay, now we can easily find b, c and d by using substitution method, but you cannot find a by using substitution method. So let me find those by using substitution, and then I'll come back and I'll find a. So here, so c, b, d I can find by using substitution. So b equal to, so for the given function, 3 over s plus 2 s plus 3, eliminate s square and put s equal to 0. So I'll end up with b equal to half. C, 3 over s square, I mean it's a complete h of s or given transfer function, except denominator of s minus s plus 2. So put s equal to minus 2, find c value and d value. I found those I found the b, c, d by using substitution method. Now going back, how to find a. So to find a, what I'm going to do, I'm going to do the LCM method. So here, I mean the LCM for this is s square, s plus 2 and s plus 3, but it's not bad idea taking all s and s square s plus. It's just like if you have 7 by 4 plus 9 by 5 plus 5 by 3, something like this. How do we do this? How do we add them? We'll take the common factor. Since there is no common factor, we'll take all 3 terms. So multiply the first term 7 with other 2 denominators 5 and 3 plus 9 times same thing other 2 denominators plus 5 times other 2 denominators. Okay, I did the same thing here. So a multiplied by other 3 denominators s square, s plus 2, s plus 3. b is multiplied by other 3 denominators s plus 2, s plus 3. c is multiplied by all other denominators s square and s plus 3. d is multiplied by s square and s plus 2. And in the denominator I have all 4 terms, but you can see s is common everywhere. So I ended up with as times s plus 2 s plus 3 plus b times s plus 2 s plus 3, c times s square s plus 3 plus d times s square s plus 2. So here the LHS side, I mean left hand side, I have 3 over s square plus s plus 2 plus s plus 3, or HS side, where right hand side also I have the same denominator. So denominators are same, so numerators must be equal. So on the left hand side I have only 3, but I can write that as 0s cube plus 0s square plus 0s plus 3. Since I have 3 poles here, actually I have fourth order, but when you look into the right hand side I started with s cube, so that's the reason I took s cube. Okay, so now if you equate s cube, 0s cube equal to as cube plus cs cube plus ds cube. Okay, a plus c plus d equal to 0. So this is s cube term. Sometimes you can write this way, s cube term 0 equal to a plus c plus d. I already know c and d values from the substitution method. I can find a. So with this I'm done. But if you continue, you can find other 3 terms also without substitution method. So now the second one is here. I did s square term, make it equal, and I end up with second equation, and this is s term and this is the constant. Okay, so by using all these 4 equations, 4 unknowns, you can find 4 unknowns, 4 equations. But to minimize this, these calculations are going to take too long. I mean, you can see it took a while for me. But if you can find substitution method as many constants as possible, the remaining terms easy for you to find by using substitution. If it is only one term, all you need one equation, we can easily find that by using substitution method. So once you write the individual terms, I have x of s equal to minus 5 by 12. That's a over s plus b over s square plus c over s plus 2 plus d over s plus 3. Now, so when we are transferring this 1 over s in the inverse Laplace transform of 1 over s is nothing but u of t. Okay, that's unit step function, or you can say 1. Okay. 1 is a constant, but to keep it in the time domain, usually we represent unit step function. We know that unit step function is nothing but magnitude changes from 0 to 1 at t equal to 0. This is t, this is u of t. So I'm going to multiply that with t. Now 1 over s square, so if this is the Laplace transformation, if I have t to the power of n, where n equal to 1, 2, 3, any number, is nothing but n factorial over s times s to the power of n plus 1. So here I have s square, so what is the n value? N value must be 1, so it must be 1 factorial divided by s square. So all I have 1 factorial s square, so 1 by 2 is a constant. I'm going to keep it on the side. So 1 by 2, 3. This is 3 by 4 e to the power of minus 2t minus 1 by 3 e to the power of minus 3t. We already did in the previous example. Okay, so this is the first example. We converted a s domain or frequency domain or Laplace domain equation into a time domain equation by using inverse Laplace transforms or table, or this yeah, let me go with the next example. Okay, so here is the next example. F of s equal to 2s square plus 4s plus 1 over s plus 1 s plus 2 whole cube. Okay, now here, what is the order of the denominator? 3 plus 1, so the denominator is, you will end up with s to the power of 4. That's the order of the this function. So it has 4 poles, so we're going to split into 4 terms: a over s plus 1, b over s plus 2, c over s plus 2 whole square, d over s plus 2 whole cube. So I have 3 repeated poles at s equal to minus 2. Now, as I mentioned, a and d, the first term, I mean s plus 1 and s plus 2 whole cube, those two terms we can find out by using substitution method. That's what I did. I end up with a equal to 2s square plus the whole function except denominator of a. So 2s square plus 4s plus 1 over s plus 2 whole cube. Now substitute s equal to minus 1, end up with a equal to minus 1, and 2s square plus 4s plus 1 over s plus 1, substitute s equal to minus 2, end up with d equal to minus 1. Now I have 4 constants, but I found only 2 by using substitution, so I need to find the remaining 2. So I'm going to find the common factor there. Here I'll end up with s plus 1 and s plus 2 whole cube. So a times s plus 2 whole cube plus b times s plus 1 and s plus 2 whole square, c times s plus 1 and s plus 2, d times s plus 1. Okay. So left hand side and right hand side denominators are same. So this is equal to the given function. What is the given function? I have 2s square plus 4s plus 1 over s plus 1 and s plus 2 whole square. That's the given function. So these two are same, denominators are same, so numerators must be equal. So if I equate the numerators, 2s square plus 4s plus 1 on the left hand side, I kept it on the left hand side here, f of s, must be equal to a times, now I'm expanding s plus 2, s square plus 4s plus 4, plus b times s plus 1 and s square plus 4s plus 4, c times s plus 1 and s plus 2, d times s plus 1. Okay. Now, if you equate s cube term, here I don't have s cube, so it's a 0. Must be, here I have a s cube, so a, and b has s cube, c doesn't have, d doesn't have. So a plus b equal to 0, a equal to minus b. We already know a equal to minus 1, so b equal to 1. Now, so if we equate s square, so I have 2 on the left hand side. So s square here, I have 4s square, if I multiply this, plus 2s square. Those are the s square terms here. Okay, so 4 plus 2, 6, 6a. So 6a, here 5b plus c must be equal to 2. So I already know a value, b value. If I substitute, I end up with c equal to 3. Okay, so by substitution method, I have a and a d by calculating or by finding, by equating the numerators of this two equations. I end up finding b and c. Okay, now I have f of s equal to minus 1 over s plus 1 plus 1 over s plus 2 plus 3 over s plus 2 whole square minus 1 over s plus 2 whole cube. Okay, now we need to convert this into time domain. Okay, so converting time domain, 1 over s plus 1, so e to the power of minus t is nothing but 1 over s, or at. Let me put it as at, e to the power of minus at equal to s plus a. So here I have s plus 1, a equal to 1, so e to the power of minus t. Same thing here, second one, e to the power of minus 2t plus 3 times. So here 1 over s plus 2 whole square, so the Laplace transform, so n factorial over s minus a, n plus 1 is nothing but t to the power of n times e to the power of at. So what is n here? Let me choose n equal to n equal to 1, so s minus a whole square, that's what I have, where n equal to 1, a equal to minus 2, basically a equal to minus 2. So if I substitute it, I'll end up with 3t e to the power of minus 2t. Now here I have s plus 2 whole cube, so s plus 2 whole cube, so here n equal to 2 and a equal to minus 2. So to write this, t to the power of n is nothing but t square, and I have to have n factorial in the numerator. Since I do not have n factorial, I'm going to multiply and divide this 2 by 2. So when I do that, I can pull the 1 by 2 outside, so I have 2 over s plus 2 whole cube. Now I can write this inverse Laplace is nothing but t square times e to the power of minus 2t. So by using this, it is nothing but s minus a cube is nothing but, so n value is 2, so I have to have 2 factorial in the numerator. So that's how I substituted or multiplied and divided by divided that function with 2, multiplied and divided that function with 2. So I end up with this, and at the end, as usual, I'm going to multiply this with u of t. U of t is nothing but unit step function. It's not going to make much difference. Okay, thank you.